Hello there, welcome to the June 2018 applied paper. Here we're looking at question 3. So Nazir is playing a game with two friends. The game is designed to be a game of chance, so the probability of Nazir winning each game is 1/3. Nazir and his friends play the game 15 times. Find the probability that Nazir wins the game exactly 2 times. So the first thing we have to do before we get started in this question here is we have to state that we'll set x to be a binomially distributed probability with 15 trials with a probability of succeeding in each trial of 1/3. So now for part I we can write the probability of x is equal to 2. Now the way we'll calculate this is by using our calculator. So go to hit menu and then go to mode 7. For this one you want binomial PD mode. PD is for probability distribution, which is when we want to work out the exact probability of just one number of outcomes. So example here, 2 games winning. So press 4 and then we want variables, so we will press number 2. And then we type in all our key statistics. We want to win 2 games out of 15 with a probability chance of winning of 1/3. Press the equals button and you get your answer, 0.0599. So there we are, that's the answer for part I. That's part I. Now moving on to part II, more than 5 games. Now that's going to be a little bit more of a difficult calculation to work out. What we do have in our calculator is the probability CD mode, but what that will work out for us is the probability of winning a certain amount of games or fewer. So what I could work out is the probability of winning 5 or fewer games, and then just work out the opposite probability of that and do 1 minus the probability of winning 5 or fewer games. Because when it says more than 5 games, that's referring to 6 games or more winning. However, we want to work out, so therefore the opposite is going to be the probability of winning 5 games or fewer. So we'll go to the binomial CD mode on our calculator. So you have to go to option 7 and then you have to scroll down once and it's option number 1, binomial CD. We'll hit variable again, so option number 2, and we want to work out the summation of all the probabilities up to 5, starting from winning 0 games, 1 game, 2 games, 3 games, 4 games. That's what it means for CD. CD stands for cumulative distribution. Cumulative distribution. So it's going to accumulate the probabilities as you win more and more games. So it's going to be for the probability of x is less than or equal to 5, this mode here will work out the probability of winning 0 games, 1 game, 2 games, 3 games, 4 games, and add it all together for you. So we'll hit enter, and it's going to be 1 minus 0.6184 roughly. So this is the probability of winning 5 or fewer games, but we want to answer the question of what's the probability of winning more than 5 games, which is 6 or more. So what we'll do is we'll store this value as option A, as variable A rather. So press the STO button and then hit the button above it to store this value as A in your calculator, and once you've done that, that screen should appear there. It should say stored to A. Then go back to the main mode on your calculator and then just do 1 minus A, and it will give you 0.382 to 3 significant figures. Okay, so that's the answer to part A. Let's move on to part B now. Nazir claims he has a method to help him win more than 1/3 of the games. To test this claim, the 3 of them play the game again 32 times, and Nazir won 16 of these games. Stating your hypothesis clearly, test Nazir's claims to the 5% significance level. Okay, with this question here, we have to set up our binomial distribution first. So we're triangling it now for 32 times, and we have a probability chance of winning of what we assume to be a third until we're proven otherwise. The null hypothesis, which we label with a H0, is that the probability will remain 1/3. Otherwise, Nazir can increase that probability to more than 1/3. So we'll assume this for now, unless we have enough evidence to prove that it's probably now increased to more than 1/3. And what we're thinking here probably is, well, out of 32 times, if Nazir's won 16 times, then that's more like a probability of a half. But was it maybe just chance that Nazir won 16 times out of 32 if the probability was still 1/3? So we've got to eradicate this probability that Nazir may have won 16 times just out of chance. You'd expect him to win about 10 or 11 times, so it's feasible that 16 could have been won just by chance, with the probability still equal to 1/3 of each of those games being played. So what we have to do to prove whether it's stayed at 1/3 or increased to something more than 1/3 is to go to our calculator, and we'll do a hypothesis test on our calculator. What we need to work out is the probability of x being more than or equal to 16. Now you're probably thinking, well, why more than or equal to 16? Because he's won 16 games. Well, the reason we have to go more than or equal to is because what we're testing to see is whether 16 is the number of games he's won or more, such that the probability will have changed. So if we think that Nazir has some advantage in winning 16 games, then he must have some advantage in winning 17 games, or 18 games, or 19 games, or 20 games. So we're testing to see what the probability of Nazir winning 16 games or more is, to see if that is very unlikely that he will win 16 games or more. So what we do is we'll go to the calculator, we go to binomial CD mode. Now to work out the probability of 16 games winning or more, we have to do 1 minus the probability of winning 15 games or fewer, because that's the exact opposite probability. 16 games or more or 15 games or fewer, they're exact opposites, so it must be 1 minus, because probabilities should add up to 1 in total. So we'll go to option number 1, binomial CD. We'll hit variable again, so option number 2. We want to work out the probability of winning 15 games or fewer, and what we're doing is we're testing this to the 5% significance level. So we're looking for, in fact, we probably want to write that down at the top. Significance level equals 5%. Now what that means is if this probability comes out to be more than 5%, then there's a more than 5% chance that Nazir has won these 16 games out of 32 just by chance, with the probability still being 1/3. And we're looking for that probability to actually be less than 5%, because when Nazir has less than 5% chance of winning these games by chance, we think, well, less than 5% chance of winning 16 games or more, that's very, very unlikely, so it must be the case that the alternative hypothesis is true. So let's see what this probability comes out to give us. It's 1 minus 0.9623, and then when you store that value as A and then do 1 minus it, you get 0.0377. So therefore, the probability of winning 16 or more games is only 3.77%. Now that is so unlikely that Nazir would have won 16 games or more, that what we have to therefore conclude is that the probability has probably increased. Nazir probably has some strategy to win this game, more likely than just the probability of 1/3. So therefore, we reject the null hypothesis, and then we can link it back to the context of the question. Nazir probably Nazir has increased the probability of him winning the game. So make sure with this hypothesis test, you always link it back to the context of the question. Yes, you're either going to reject the null hypothesis or accept the null hypothesis. In this case, we're rejecting the idea that the probability is still a third, so therefore we now think that the probability has increased, or Nazir has increased the probability of him winning. So there we are, that's the answer for question 3 there, worth 7 marks in total. Let's now move on to question 4.